Hi everyone, and welcome to example 1 on page 23 of the workbook. And this is going to be our first example of actually using the midpoint and the trapezoid rule to estimate the value of an integral. Okay, so we're starting with the function f of x equals the square root of 40 minus x squared. Okay, and part A of this is asking us to use the midpoint rule and the trapezoid rule, both with n equals 3, to find two estimates of the integral. Okay, so let's just pick one and start with it. Okay, maybe over here on the left, we'll draw a picture of the midpoint rule. Now, one comment, the n equals 3 is just telling us how many pieces to slice our interval up into. So we're integrating from 0 to 6, and we want to break that into 3 equal pieces. Okay, so that tells us then that delta x, the width of each piece, is just going to be 6 minus 0 over 3, which is going to be 2. We can kind of see that in the picture, that the width of each subpiece that we have is 2. Okay, now remember how the midpoint rule works again. We're going to go to the middle point of each interval, and we're going to draw in a rectangle that has its height kind of given by the output value of the function at that center point. Okay, so I'm going to draw in the first midpoint rectangle. The second one's going to hit the curve in the center point. And same for the third one. Okay, so there are the 3 rectangles that we want to find the area of to get our estimate of the integral. Okay, so if we start then by writing out what the formula for the midpoint rule looked like, it looked like delta x multiplied by the heights of our rectangles. In this case, we've got 3 of them. So we're going to have f of x1 bar plus f of x2 bar plus f of x3 bar. Okay, now remember what those points, x1, x2, and x3 bar, are equal to. They're just the middle points of each of our intervals. Okay, and so if we highlight them, they're going to be there, there, and there. And notice from the picture, we can see that those numbers are going to be 1, 3, and 5, okay, on the axis. So that just means to do this calculation here, we're going to start by filling in the value of delta x, which we saw above as 2, and then we're going to substitute in 1, 3, and 5. Those are the values that we need to substitute into our function. Okay? So next, we need to remind ourselves what the formula for the function was. It was sitting up here. So for example, f of 1 is just asking us to take 1 and substitute it into that function. So we're going to get the square root of 40 minus 1 squared. Then we come to f of 3, same idea. Okay, and finally f of 5. Okay, those 3 numbers are going to give us the heights of our 3 rectangles. And the rest of this is just punching that into your calculator and seeing what you come up with. That's going to be about 31.37. Okay, and that's the first part of our answer. That would be our estimate of the integral using the midpoint rule. Okay, well, what about the trapezoid rule? Let's draw a picture of that on the graph to the right here. Okay, well again, n is still 3, so we're still chopping this into 3 pieces. And for the trapezoid rule, we're not using rectangles, we're using trapezoids to get our areas. Okay, so if we draw those in, okay. Whoops, you can see my drawing skills are a little lacking here. Okay, but roughly speaking, that's what our 3 trapezoids would look like. Okay, and to get our estimate, we need to actually find the area of those. Okay, this is going to give us an opportunity to just observe for ourselves some differences between the midpoint and the trapezoid rule formula. Okay, so I'm looking back at the formula that we came up with on the previous page for the trapezoid rule. It looked like delta x over 2. That's one difference. And then another interesting difference is that the trapezoid rule formula actually has 1 extra term. Okay, even though n is 3 for both the midpoint rule and the trapezoid rule, we have 1 extra term. you might remember that we made the observation that we get 2's in front of all the terms in the middle, and it's the first and the last term, in this case the f of x0 and f of x3, that just have 1's in front of them. Okay, what do we mean when we say x0, x1, x2, and x3? Well, in contrast to the midpoint rule, where we took the middle points, in the trapezoid rule, we're just taking the partition points themselves. So those numbers would be these 4 numbers that we're seeing here, just the numbers on the edges and not the midpoint. So if we fill those in, we're going to get delta x over 2 times f of 0 plus 2f of 2 plus 2f of 4 plus f of 6. Okay, let's make sure that we're not going to run out of space here. And then fill in the pieces. So let's see, delta x is 2. We're going to divide that by 2. And then we're going to go to our function, square root of 40 minus x squared, and plug 0 in. Okay, and then do that for the rest of our partition points. Plus 2 times the square root of 40 minus 4 squared. And then finally, no 2 in front of that last term, 40 minus 6 squared. Okay, make sure we've written that down right, and then that again is a job for your calculator, and you're going to get an answer of about 30.12. Okay, so we have answered part A, and we got 2 different estimates of the area under the curve using the midpoint rule and the trapezoid rule. Okay, so onward to part B here then. Okay, now they're asking us to analyze our estimates a little bit. Okay, they'd like us to know, is M3 an overestimate or an underestimate of the area under the curve, and how about T3? All right, well, let's start with T3 because I think that's a little bit easier to see. Okay, so what do you think? If you look at the picture here for the trapezoid rule, and you look at the areas of the trapezoids that we drew in, what do you think? Are we going to get too much or too little area? Notice that those trapezoids miss a little bit of area, these 3 areas here and here. So looks to me like we're going to get an underestimate of the area, okay, using T3. Okay, and if we want to just give a brief explanation there, because all 3 trapezoids lie below the curve. Okay, what about the midpoint rule? Okay, could we make a statement about that? Now this is a little bit harder when you look over here to the picture on the midpoint rule, because part of the rectangles stick up above the curve and give us too much area, and part of it is too low. Okay, so what we kind of need to do is to compare both sides. So I'm just going to pick one of these rectangles and compare this area with this area. Okay, so we're kind of getting extra area on the right, area that we don't want, and then we're missing some area there. Now this is a little bit hard, but if you look really closely here, you might notice that the extra area that we're getting is a little bit bigger than the area that we're missing. And I think if you look carefully and maybe draw your picture more carefully than I did, you might notice that that's the case for all of those rectangles. And that means that with the midpoint rule, we're actually getting an overestimate of the area, slightly too much area. Okay, and I'll say it this way because we get more extra area on the right-hand side. Than we miss on the left-hand side, something like that. Okay, you might be able to find a slightly better way to word that than I did. Okay, and then the final question is, could we use that observation to give an improved estimate of the integral? Well, kind of what I'm thinking there is if T3 is an underestimate and M3 is an overestimate, maybe we could average the two to balance our error out a little bit. Okay, so a good overall estimate then, or an improved overall estimate of our integral would be just to average the two. Okay, so I'm going to take the 31.37 and the 30.12, add them up and divide them by 2, and 30.75, whoops, sorry, we're going to get 30.75. That's a slightly better estimate of the area than the previous two that we had.